Alright guys, making sure that our recording at least has the max volume possible. If you couldn't do your homework or it was difficult because page numbers were off, yeah, the electronic versions of the book seem to either have the different page numbers or no page numbers at all. So I revised the Chapter 2 homework to not refer to page numbers and instead tell you what section they are, which is a little bit less convenient if the page numbers were correct, but it's better than not having any page numbers at all. So hope that helps, and I will continue to do that for further assignments that would otherwise refer to page numbers. So we're going to have a couple of homework assignments after today. Oh, and by the way, if an assignment is late, this is more for the online students, but if an assignment is late because a video was delayed or lost temporarily, then when you upload your homework for it, just put a note on there saying, hey, I couldn't find the video until you upload it. You know, you don't have to be snarky about it. Delayed because of, delayed video. Just put that on there, and that way, if it's a daily assignment, I'm probably not going to count it off anyways. But homework could also be difficult if you hadn't watched the video for it. Let's see, anything else along those lines? Don't think so. All right, so programming assignments. These are actually from the book. So I want you to do problems 2.1, 2.2, and 2.3 from the book, shown for your convenience. Write a program that displays the dimensions of an 8.5 by 11 sheet of paper in millimeters. There are 25.4 millimeters per inch. Use constants and comments in your program. Constants? I don't quite recall how to define a constant in Python. Let's look that up. How do I create a constant in Python? Is there a way to declare Python? No, there really isn't a way. Alrighty. I don't know why he was talking about a constant, or, in the author of the book. If you can find a reference to constants in Chapter 2, that's totally cool. I don't get it. So, do comment your code, of course. Put up at the top a comment block with your name and the date and what homework assignment it is and whatever. So, part 2, write a program that computes and displays the perimeter of an 8.5 by 11 sheet of paper and the length of its diagonal. And write a program that reads a number and displays the square, cube, and fourth power. Use the star operator only for the fourth power. So in other words, you're going to do x times x, and then you're going to x times x times x, and then for the fourth power it's going to be x, star 4 to get it to the fourth power. You can put the solution to all these problems in the same script or submit 3 separate scripts. Hint, the diagonal of a rectangle can be calculated as the square root of the it's just the Pythagorean theorem. Width squared plus height squared, take the square root of all that. If you can't figure the formula out, text me, I'll send it back to you. And the perimeter of a rectangle is 2 times the width plus 2 times the height. Alright, then there's a little bit more. This is a really simple little turtle program. If you've taken my basics 1113, you're used to turtles. So this one's incredibly easy. All you do is define the functions, it creates a turtle, and it looks like it draws a square. How do I know it draws a square? It draws 4 lines. 1, 2, forward, 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 forward. And then it only has to turn left 3 times because, you draw one line, you turn, draw another line, you turn, draw another line, you turn. The function takes a parameter, so we pass it an argument of 150, and that's the size that's used for each line. Really, really short script. So this homework should not be too hard. And there's another one. This one plays a little bit with the idea of defining a function and then how to call it. So we're going to launch setPython.command. I think we need to revise this a little bit because I don't have y'all create a setPython.command. But here's something to try. Now that we have Python installed on these machines, let's see if we can run Python from the command prompt. Python. Woot, I can. That's pretty cool. You may not be able to on your machine at home. You may not be able to on the machines here. That means that the search path is not correctly defined. Alrighty, fine. Okay, there we go. I had to type exit parentheses in parentheses to get out of Python. So if you can load up Python in a command shell, that means you can run scripts from the command shell, from the command prompt. If you can't, you can't. If you type path, you'll see the search path. And if you don't see mentions of Python directories, then it's just not going to work. So I'm going to take out, well, I may leave in there and just say if this doesn't work, that's okay. So point 1 is going to go away completely. Let's actually work on some of this stuff rather than just talking about the homework assignment. So I'm going to go ahead and create in the shell, not in a script, a Python function. Define double me, parentheses x, colon. So we're defining a function called double me that accepts as an argument a value x, which is copied into this parameter here. And then we're going to return 2 times x. That's all the function does. Now I can call it, print double me 10. And it's going to print 20, right? So now we're going to create a function, but we are going to actually call it from the command prompt. So let's do file, new file. Do a save as to get this into your favorite code directory. Mine goes into scripting. I'm going to call this one Aug 31st, AUG 31st. And just to double check something, firstly I'm going to close this shell here. Then I'm going to reopen the shell. And if this doesn't work right, I'm just going to skip past this part of the assignment. And I'm going to type import aug31.py. No such module named August31. Import aug31. No module named aug31. Alrighty. That kind of gets rid of some of the other stuff that I wanted to do. We should be able to do an import and get whatever script file we have written to load within the shell. We could do that if we place the py script actually into the Python subdirectory tree itself. Or if we could launch idle from within the correct directory. But I don't know how to guarantee that. So the assignment is going to be changed erratically. At one time I had everybody create a set CMD function which would launch idle in a specified directory so that you could then import from that directory. And I no longer have people do that. I may come back to the idea later. So this is going to be remarkably changed after we're done. By far most of the this homework is going to go away. I apologize for that. The goal was to show you that once you write a script, you're creating your own module that you could use import on. And once you did that, you could call it from here. But we can't unless we put our py files in a specific Python subdirectory in the directory tree. Yes, sir.
I don't know if it'll work on Windows, but on Linux, I opened a command prompt where I have all my scripts, and then I ran Python.
Exactly, that would work. So if you can find your scripting directory from the command prompt, and if you can load Python from the command prompt. Let me get a larger font for everybody. Very, very good point. If you go into the directory and then launch idle, you are good to go. So you just have to figure out where your files are stored. My files are stored off the desktop, so CD desktop, and then CD into scripting. And if I do a dir, I see some py files. If you can do that, great. I'm going to actually put something in that script I was about to create. Let me find it again. I guess I closed it in frustration. Alright, so with the August 31st script back open, just going to make a dummy little function. Define hello, parentheses in parentheses, quote, colon, and then print hello there, then return. Let's write two versions of it. A version called hello2 that takes a name as a parameter. So define hello2 colon name, print hello comma, let's take the comma out, that'll just be confusing. Hello, and then outside the quotes a comma followed by the name, and then the return. And are the return statements strictly necessary? No. If you're not returning a value out of the function, you don't have to have return at all. But I find that it kind of visually breaks up the code, makes it a little bit easier to look at. Okay, I'm going to save this. And then I'm going to come over to my command prompt. Let me shrink it a little so that we can get all of this on the screen at the same time. And if I do dir aug 31st asterisk, I'll see my new file with the new date and stuff like that. If you do dir and you can't find your new Python script, then what I'm going to show you next doesn't work. Having done all of that, I'm going to close everything. I'm going to close all my idle windows. Close that. Close that. Then I'm going to launch idle again. But I'm in the same directory as my August 31st script, or whatever you called it. So, IDLE doesn't work. Foobar. So Python is in the script, but idle is not. So in your Linux setup, idle is also mapped so that you can launch it from the command prompt from your.
You just type in Python.
Well, that'll work. Okay. So if we type Python, it brings us into the raw shell right here. We don't even have idle open. We just have Python. So we're good to go here. We could import August 31st, and now those functions are available to us. Hello, parentheses in parentheses. Hello is not defined. Import aug31st.py. There is no script. Import aug31st. There should be two versions of our hello script. We made one called hello2. I know what I'm doing wrong. Two versions of the import statement. There's import, which brings in all of the functions in that, but to use them you have to preface them with the name of the script. August31.hello will print hello there. And then August31.hello2, parentheses, and then let's follow it, put a name in there, will print hello Jeff. So you see what I did? Since I did import aug31st, that is one method of doing an import, and then every function in there I had to prefix with aug31.hello. And for those who took my prior class, the turtle libraries, when we did import turtle, that gave us all the turtle functions, but we had to prefix them with the word turtle. So if we wanted to create a new turtle, we did, t is equal to turtle dot, turtle, that kind of stuff. The second way of doing it is to say from Aug 31st import hello. There's not. I typed uppercase rather than lowercase. From lowercase, Aug 31st import hello, whatever you called your script. Or if you're just watching, that's cool. Now I can type hello and it runs it, and I don't have to prefix it with the name of the file. See that? So just remember that you can import a library, or you could say from, don't type this, from library import, and you can list a specific function. Foobar, like that. If we were going to call foobar after doing it the first way, we would have to call library.foobar. If we were going to call foobar the second way, we would just call foobar because we imported it directly. We said we want this function foobar available, so from library import foobar. Those are the two differences. Alrighty, let's close all of that. Get back into idle and see if we can invoke that function from another file. So I'm going to do file, new file. I'm going to save this in the same directory. Since we already have something called Aug31, I'm going to call it Aug31B. Real clever name. Alrighty. Aug31b.py. So, very first thing I'm going to do is establish that this works. So I'm just going to type that, save it, and run it to make sure I don't get an error there. Okay, that worked. Why did it work? This py file and the other one are in the same directory. So it was able to import it cleanly into it. Meaning I can run the hello script. Even though I don't see it up here, So, by the way, this is the same thing essentially as # include if you're a C or C++ programmer, or import if you're a Java programmer. And there's a C# variant that escapes my memory just at this moment. Okay, so that's one way of importing it. Let's import it the other way. From Aug31 import hello2. Now let's call hello2 we did not have to prefix it with the name of the script. We did not have to type aug31.hello2. So they both worked. So what I want you to remember is if you have multiple py scripts in the same directory, you can load one of them and then you can import the others into it. Why would you want to do that? Well, if you're working on a very large project, there's probably going to be a lot of py scripts in it. You don't just want one script that's got 10,000 lines in it. You want a whole bunch of scripts, each one that you can import as you need it, so that that code could be shared through other projects. Now this isn't really covered in the book, so that's kind of why we went on this separately, and it's why I'm going to give you a homework assignment based on this concept as well as talking about it in class. Good time to pause and see how people are. So we're looking at one file right now, but we really need to keep the other one on the screen as well so you can compare them. This is aug31.py and this is aug31b.py. Alright, I believe chapter 2 covers you the thing that I'm going to show you next, which is if you want the Ascii value of a character, you can get it. I haven't talked about Ascii values in this one, but every number, every letter, every symbol that you can type in on your keyboard or any other keyboard has an associated value. So let's get a value and then find the Ascii value of it. So I'm just going to say C is equal to input, parentheses, quote, type a character, and hit return. Now what if they decide to play funny and type in a string rather than just a character? Let's get only the first character. And this is dealing with lists, you know, and strings, which we haven't really covered. So just bear with me on this one, that this gets the first character and stores it back into C. Now let's print that character followed by the ordinal value of that character. So ORD is one of the built-in functions. That's why it's purple on our editor. So I'm going to type in a character and return just like it asked me to. I'm going to type in capital A and see what it printed. 65. This is not actually just the ASCII value of it. It's really what's known as the Unicode value for it. But the Unicode character set encompasses ASCII and then every other language known on earth. So, you know, if you need to type in kanji, Japanese, Chinese, you know, Russian or whatever, all of those characters are in that character set, the Unicode character set. And it's increased from time to time to add additional things to it. So when I ran it, it told me that an A was a 65, which is all well and good, because if I go to the command prompt, not to the command prompt, to the browser, and type in ASCII chart, and just pick one, likely looking one, we will see that a 65 does indeed represent an A. And since computer memory is just a series of zeros and ones that are treated as numbers, you know, somewhere in computer memory there's the binary numbers that represent a 65, and that turns it into an A. Say that we wanted to turn a number back into the ASCII value. We can do that with CHR. Ordinal gets the Unicode value out of it, and CHR converts a Unicode value back to a character. So let's do 66, because we saw that a capital A was a 65. And then the CHR value of 66. You know, it'd be more fun to put that in as a variable and then we could change it. So type in a character and hit return. I'm going to type in a capital A again. Not that it has magic powers, but because I know that its number is 65. And so when I printed out 66, the character version of it is a B. We're going to use that in a later assignment where we implement a cipher. A cipher takes text and scrambles it in a certain way to make it harder to read. Now our ciphers, the primitive kind of ciphers that we're going to explore in here, you know, worthy of, you know, really protecting your text, the NSA won't be able to crack it. No, that's not true at all. But we're going to get the idea of a cipher. So I do want you to understand that. That is covered a little bit in Chapter 2 in your reading assignments. I do specifically ask you to read it. So if I gave you a chapter assignment that instead referred to the online textbook rather than the paper or ebook version of it, I would very specifically call that out. So you shouldn't have to text me or email me asking whether something came from the online textbook or the chapter textbook. And I totally understand the people who did that because the page numbers were wrong, you know. So, but you shouldn't have to do that anymore. I will specify, and I will even give you the URL in the text of the homework if I wish you to do that. Alright, as far as I'm concerned, we have covered everything I wanted to cover in Chapter 2 of the physical textbook. But we're going to go to the online one. Anybody need any more time to type that in or to understand what it does? Run it a couple times more. Type in a capital Z or an exclamation point, or it's hard to get it to accept a space. You know, a number, and you'll see that each keystroke that you can make on a keyboard has a different numeric value. which makes sense because as far as the computer is concerned, everything is a number. And it's just by whim of us defining character sets that turn numbers into letters that it can, represent things to us in a language. Okay, so quick links, textbooks, online textbook, books.trinket.io. Chapter 2, variables. So we know what a variable is. A variable is something that has a name and a type, and it contains a value. And it can actually be a very complex type. Some variables reference something that actually have a whole bunch of values. If you're doing some kind of graphics and you have a turtle that has an X and a Y position, it's got to contain those things, and it's got to contain the color of the turtle and all sorts of things. So one variable can contain a whole bunch of different values. But right now the variables that we use just contain one value rather than a whole block of values, and those blocks are called objects. So we can give variables any names that we want to, with a few exceptions. I'm going to launch Python, just go back to the shell, and see if I can give some variable names. M is equal to 30. That's great. 3M is equal to 30. Syntax error. This language and a lot of other languages do not allow variables to start with a numeric value. They have to start with a letter. Now the letter could be in, Romanian or Hungarian or, or Russian or whatever, but still has to be a letter, not a number. There are a lot of special symbols that cannot be used as a variable name. Periods are not allowed. Underscores are. So if you want to use underscore M, why would you want to? What you use underscores for is if you wanted to do, temperature of patient is equal to 30. You could do that. You can separate all the words in your variable name with underscores. Why do you do that? Because you can't use spaces. Temp of patient equals 30. Won't work. A more common way of doing it anymore is to use what's known as camel case, where you use uppercase letters to break up the words. Temp of patient equals 30. Now when I was learning programming, underscores were all the rage. And then as time went by, this became a more popular fashion. If you like underscores, I think they're great. I'm not going to count off or whichever way you use it. If you give it an illegal name, you will get a syntax error, regardless of whether you're in the shell or whether you're running a script. 76 trombones is a bad name because it starts with a digit. @ signs are illegal, just like almost every other form of punctuation. Some languages allow $signs, some do not. Let's see if this one does. A $sign is equal to 30. Syntax error. So $signs are not even allowed. Pretty much the only punctuation you can get away with is the underscore. Something to be warned of is that unlike a lot of languages, you can even redefine functions and assign them as variable names. What do I mean by that? Excuse me, I'm going to close this and then reopen it so that I'm typing up at the top of the screen. Okay, print equals 34. Great. Now what happens if I try to use it? I want to print hello. Can't do it. We have redefined the entire meaning of the word print. Python is what's known as a loosely typed language, meaning that just because that was defined as a function at one time, you can redefine it anything you want to. Now we could fix that. We can just close the shell and reopen it. It's not a permanent change. But in your program, if you happen to do print is equal to 34, then underneath everything, no longer see that. And I tend to run into that problem when I type sum is equal to 1 plus 2 plus 3. As you see, sum is a purple word. It's actually a function. After I do that, I will no longer be able to call that function. Is a big deal? Well, probably not. If I'm going to calculate sum like that, I wouldn't be using a sum function. But so whenever you're typing your code in, just watch for the colors, and if you happen to type a variable name that shows up in purple, it's bad news because you're overriding the meaning of a function name, a built-in function.
But there are built-in functions that you can't override, right?
There are keywords.
Keywords.
Yeah. Yeah, the difference between a function and a keyword is a function is a chunk of code that's associated. I'm going to close this and open it back up. A function is a chunk of code that's associated with a word. Well, that's not right. So if we call sum on a list, it would add all the values of that list together. I did the wrong syntax there. I'm going to take one more stab at it and then give up if it doesn't work. Like that. Okay, so that's a built-in function, but then there are keywords like if. They're colored differently because they're not a block of code. They actually define the language itself. And you can redefine these guys, but you can't redefine this. You can't say if is equal to 34. Very, very good question. Bless you.
If you define a function and you call it later on in your code, it doesn't come up as the built-in function color though, right? It's a different color.
If you're using a good editor, it would come up as a different color. Okay, the question was if we define our own function, does it colorize it the way that it does the built-in functions? And unfortunately, it does not. It'd be really nice if this was a different color to represent that it was our own built-in function, but idle is not sophisticated enough. I don't know if PyCharm, I don't know which Python editors would do that. Things like Visual Studio and NetBeans and Eclipse, editors for Java and C# and C++ do that to make things easier to use, to figure out all the different keywords. By the time we're done, we're going to know what the vast majority of these keywords mean. So a statement is a unit of code that the Python interpreter can execute. Assignments, x is equal to 2 is a statement. Print is a statement. DEF is a statement. Okay, pretty much every line of code except for a comment is a statement. Operators and operands, we covered this last time. Plus, minus, asterisk, double asterisk, those are all operators, and the operands are the values upon which the operators work on. So 5 to the power of 2, we have our operator, the exponent operator, and the numbers that it works on, 5 and 2. This is what's known as an expression. An expression is a series of values which can either be literals, like 5 and 2, or they can be variables, and operators. At its bare minimum, an expression can just be one thing. X is equal to 60. The 60 is an expression unto itself, but more typically, if you say something is an expression, you mean it's something like that. On a grade school test, if you were just supposed to solve something and all it said was 3, that'd be real boring, you just write a 3 underneath it. It's much more interesting if it says 3 plus 2. That's an expression that's worth thinking about. We know what a division operator does. I believe I covered floor division, is that correct? Yeah, that just rounds down. 59 minutes divided by 60, well, 59 is smaller than 60, so it rounds down to 0. It doesn't say 0.999 or whatever, which is what it would do if we just had a single slash. Order of operations. We talked about PEMDAS, I believe. Multiplication, division, exponents, and floor division are all higher priority than addition and subtraction. Other than that, if everything is of the same precedence, it's just solved left to right. We talked about modulus, which means remainder. String operators. You can use a plus sign to add things. And I got a text message saying that multiply, where you do something like this, A is equal to 250, 350 times, hello, I need to print out A, that was actually useful for trying to do a buffer overrun security test to see if you could give something enough data in order to choke it. How would you, A8 is equal to, A is equal to 10,000 times, hello, still works. It's going to take a while to print it all. Okay, it's going to take a real long time to print it all, but there it is. We have 10,000 hellos in a row. asking the user for input. You can either use the input statement all by its lonesome, or you can pass in as an argument a string that you want to be displayed. So this would be horrible. Input is equal to input. I don't even know why they would do that, because they're overriding the input function right there. So no, no, no. Do not ever use input as a variable name. That's a I'd like to have a word with the author of this online text. This is better. Name is equal to input. If we didn't put an argument inside the parentheses, it wouldn't display anything. But you can put a print statement before it. Print, what is your name? And a name is equal to input. /n represents new line. Why would you care? If we do this, I'm going to go back to my script here. Type a character and hit return. When I run it, right now, I'm going to close that because I can't see what all it's doing. Run again. Type a character and hit return. Notice that it's on the same line. Ampersand. ASCII value, the Unicode value of an ampersand is 38. Okay, so that was left on the same line. That's well and good, but maybe you want it on the next line. You could put a /n here. That would force it to go to the next line before the user could type in something. Type a character and hit return. If that's what you like, that's cool. Either way is totally fine. If you put a print statement followed by an input, it automatically does this, unless you try real hard to get it to avoid it. Print, type a number. Now x is equal to input, like that. Even though there's no /n, these are going to be on separate lines. Type a character, type a number. Notice that where I'm typing it is underneath it. That was interesting. Okay. I don't know what I did there to get it to repeat itself. That's curious enough that I'm going to run it one more time just to see. Oh, I typed in something that wasn't a number. But was that really the problem? No, I don't know why it just did what it did.
Click the line above it, hit enter.
That would probably do it. Okay. Yeah, so I clicked the line above it and then hit enter. Comments. We know what comments are. Hashtag, the #. The British use the absurd term octothorpe for it, although in the day of Twitter they probably just use hashtag. Use comments to describe your program. Every function you define should have a comment. Have I been following that? Not really, because these have been pretty trivial functions. If I go back into Aug 31, we can pretty much see right there what hello does. But if you have a function that has 100 lines of code, you ought to explain what it's supposed to do. If it has 10 lines of code, you ought to explain what it's doing. It's a professional thing to do, to put comments on your functions to describe what they are. So picking good variable names, single letter variable names are pretty bad variable names. Yeah, I use them when I'm giving demonstrations up here, but when you're writing code, you ought to actually give things good names. Don't say T is equal to an input. Say temperature, or at least temp is equal, Don't say N is equal to, say name is equal to. Give yourself good names so that, when you're looking at the code later, it's far more clear what it's doing. Those are called mnemonics. Mnemonics are memory aids. If you give a variable a good name, it serves as a mnemonic for its purpose. Yeah, the movie Johnny Mnemonic. So while this all sounds great, and it is a very good idea to use mnemonic variable names, they can get in the way of a beginning programmer's ability to parse and understand code. Well, I guess that's true. Anyways, I tend to use single letter variable names a lot when I'm up here because they're easy to type, fewer mistakes when you're typing them. Yeah, I'm going to skip that one because we haven't even talked about for loops yet. So debugging. At this point, the syntax error you are most likely to make is an illegal variable name. I don't know, at this point the syntax error you're most likely to make is just typing the name of the variable wrong, in my opinion. Or leaving the colon off, you know, or tabbing things incorrectly. Python is so picky about such things. If I come and I do this, I'm going to go back to Aug 31 and make my change here. What if I use, you know, 2, 3, 4, 5, and I tab that over just a little bit off? It's no longer going to work. That's not true of other languages where you use braces to denote blocks of code. So the glossary. I don't see anything that we don't already know, right? We know what an assignment is. X is equal to 5. We're assigning 5 to X. It assigns a value to a variable. Concatenate joins two string operands end to end. I would have used the word strings there. Because if you do 2 plus 2, it's not concatenating them to make 22. It's making 4. It's doing math. It's only if you have 2 strings that it does concatenation, which is where you join 2 things together. Comments describe the code. You can start a multi-line comment in this fashion. Sometimes it seems to be a little bit squirrely, but if you want to, you could do this. Quote, 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 I love programming in Python. Print what? You know, and then a couple more quotes like that. It's not going to print what. This editor makes it pretty easy to see that that's a comment. All of it's in green. Other programming languages have their own way of denoting a multi-line comment. So this is a single line comment, and that's a multi-line comment. We will see that it won't print what, but it will print, well, it's not going to because I made a syntax error that I never corrected. I better fix that. Alrighty, recent files. I use the recent files menu a lot. Undo that. That's odd. The tab is now tabbing 5 characters rather than 4. But as long as the tabs are all the same, you're good to go. It doesn't matter what your spacing is as long as they match. All right. So it didn't print what, but it did print done because what was commented out. Read through the end of this. I'm not going to ask you to do any exercises from the online tutorial. Let's hit chapter 3, conditionals. A Boolean expression is one that returns true or false. I'm going to open the shell and type in a few Boolean expressions. So run Python shell. Is Jeff equal to Bob? Whoops. Can I type? Okay, I'm going to make it easier than that. Is 3 equal to 4? No. Is 94 less than 100? Yes, true. Is 94 greater than 100? No. True. True. False. False. These are all Boolean expressions. Boolean expressions involve the mathematical comparisons, equal than, greater than, less than. And they can also involve functions that return Boolean values. Or they can just be a single word, like true. You will see me sometimes write while true. And the reason I would do that is because I want the while loop to repeat infinitely until some condition causes it to break. So true or false are special values. They're capitalized in this language, unlike most languages. They belong to the variable type known as bool. They are not strings. Here's a list of examples of Boolean expressions. I like this one. X is Y. X is the same as Y. Does that work? Let's find out. I'm going to go back to the shell. I'm going to start a new shell. X is equal to 3. Y is equal to 3. X is Y. Is that true? Sure enough. I'm going to change the value of X now. Is X is Y? False. So it looks to me like the word is the same thing as saying equal. You know, x equals y. That's interesting. X is not y. That is true because x is 4 or 10 or whatever and y is 3. I never use the word is.
I think it does something different when you're aliasing with lists.
Yeah, I am absolutely sure it does something slightly different. And so now that you've said that, I'm going to go Google it up. I'd actually kind of forgotten that it existed until I saw this slide. So we could Google it up. What does the is keyword do in Python? How is the is keyword implemented in Python? Well, I don't want to know how it's implemented. When, if ever, to use the is keyword in Python. You'll notice that every programming question you type in usually leads to stackoverflow.com. You should use is when you want to know whether two objects are the same object. Don't use it when you want to know whether they have the same value. So, you can have two different things that have the same value, but they're not the same object, in which case is would return false, even if they had the same value. In this case, when we're using these literals, I guess they're all assumed to be the same object. Everything that's equal to 3 is considered the same object. But if you had two turtles that had all identical characteristics, the x position, the y position, their direction, their color, everything was the same, and you did turtle 1 is turtle 2, no, they're not the same. They're two different objects. Thank you for prompting me to go look that up. Logical operators. Some languages use something else for and. They use two ampersand signs. What you use and for is to chain conditions together. X is greater than 0 and y is greater than 0. That is true. X is greater than 0 and y is greater than 100. That's false. Both conditions have to be met. And means both of them have to be true before the result is true. Y is not greater than 100, so the whole thing is false. What if you only want to check one of them, though? Y is greater than 0 or, excuse me, x greater than 0 or y is greater than 100? Now this is not true, but this is. So there we go. That one returned true. So and is something like if you're hungry and you have money, go out to eat. You better not go out to eat unless you can sponge off a friend if you don't have any money and you're not hungry, you know. So both of those have to be true before you'd want to go out to eat. But or represents something where either case could be true. Are you sick or is it the weekend? Sleep in late. You get to sleep in late if you're sick and you have a nice job, or it's the weekend. We could set up what's known as a truth table for and or. That's we've already kind of covered that in 1113, I believe. Then there's not. Not x greater than 0. Of course, you could have reworded that just like this, you know. X is less than or equal to 0. Same thing. You can usually get away with using the word not just by rewriting your expression, but sometimes it makes the syntax clear. But the way our brains are wired is flipping things from positive to negative kind of messes with our brains. Like if you use double negatives or triple negatives in a sentence, it becomes way harder for you to instantly understand what that spoken word is. Which is why if you're writing an English paper, you're not supposed to use double or triple negatives unless it just is absolutely necessary. Same thing here. Okay, this is going to be dumb, but not x greater than 0. We're back to being true. Why? Because not x greater than 0 was false, but that flipped it back to being true. Would you ever do that? No. So for and, they both have to be true. For or, only one side has to be true. Conditional execution. In order to write useful programs, you pretty much need the ability to change the behavior of the program based on its input. You know, you're controlling Pac-Man. You need Pac-Man to start going one way if the joystick's pointed one way and go the other way if the joystick's going the other way. Otherwise, you just run to the edge of the screen and sit there, and that'd be really boring. So a conditional is when you have the word if followed by a Boolean expression. Is x greater than 0? Then print x is positive. So that's conditional execution. You put your expression here. The expression could be boiled down just to a simple word true, but if you did if true do something, that's kind of absurd. It would always do it. If x greater than 0, yes, print x is positive or positive. Alrighty. There's no limit on the number of statements that can appear in the body of the conditional statement, but there has to be at least one. This would be pointless to do. If I went here and I did, I'm going to type this up at the top. If 3 is greater than 4, and then I didn't do anything, and then later on I did something else, I do not, according to the text we just read, that would be a syntax error. Yeah, it expected an indented block. The block of code could just be one line, or it could be a million lines. What is a block of code? It's a whole bunch of stuff that's at the same indentation level or greater. So we're going to make a block of code. And I know I'm going faster than y'all are typing. At this point, it's okay for you just to watch. Now I'm going to write another statement. Except I want this to be true, so I'm going to make it say if 4 is greater than 3. Now, if 5 is greater than 3, we're going to do some other stuff. Print what? Print hello. Whatever. Now I'm going to stop that indentation and print one last thing out. And then I'm going to print the word whoo. Okay, so blocks of code. All of this is at the same indentation level or greater. All of that is one block of code. It also includes a nested block of code. See these two things? That's also a block of code. That block of code is subordinate to this if statement. All of this code is subordinate to this if statement. If you write a function, it's got a block of code. I'm going to toggle back to that 30 for a moment, or my first one without the B. Here we go. We defined a function and it's got a block of code after it. And the first unindented line ends the block of code. So here we have started a new block of code. A convention we're going to follow very soon is to put all of our code in a main function. Just mentioning that, we're going to hit it later. Alright, so alternative execution. If something is true, do something else, do something else. And then the third form is chained conditionals. If something is true, do that. Elif, now that's different than some languages you may have seen where you have the actual words else space if. The guy who invented Python thought elif was cool. Can't argue with him. He made it up. So if this is true, do one thing. Elif this is true, do something else. And then you finally throw in an else to catch any, if none of those things were true, that happens. This text calls that chained conditionals. You could have, 100 if, elif, 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 elifs. One and only one of these things will happen. It'll print that, or it'll print that, or it'll print that. It'll do that, or it'll do that, and if none of those are true, it'll do that. There's no number on the end number, no limit on the number of elifs. You don't have to put an else clause there. But if you don't put an else clause there, sometimes it could be a problem. If x is less than y, print x is less than y. elif x is greater than y, print x is greater than y. But if you left that off and they were equal, you wouldn't get any output at all. Maybe that'd be okay. Usually it's not. As a rule of thumb, if you have a whole bunch of elifs, put a final else. Even if you don't think that it'll ever get there, just put it there and denote that the program is in a state that it didn't imagine, that you didn't imagine when you were writing. Unexpected state, or something like that. And the reason for that is that if you just wrote these two things, and you thought that that adequately covered the situation, and then later you ran it and it didn't print anything at all, you might not notice that it didn't print anything at all. You might still think your program is working right. So you tack on one final else, a trailing else, and then put something there. Unexpected state or whatever. And then if that ever popped up, you could go and you could figure out what was wrong. You could fix your if statements or add, make your else clause actually do something useful. It's about time to stop. So let's make a Dropbox, upload whatever you did. I really doubt you typed in everything I did. That's totally okay. Alrighty, you should see a folder called C, except I left it hidden. I'm getting better about that, but you wouldn't believe it because you didn't see me do it. Alrighty, refresh your Dropbox, look again, you'll see C there. Just give me the Aug 30 and the Aug 30, Aug 31 and Aug 31B files. These two homework assignments I will make visible, and you can work on them. They'll be due Wednesday at midnight. And I will go analyze this Dropbox to make sure that it doesn't have any page numbers in it. Alright, just as a reminder, it doesn't affect us because we don't meet on Mondays, but Monday of next week is Labor Day, so if you have any Monday classes, don't come in. Alrighty, let me see if I can answer your